Welcome to another CMC podcast. In today's podcast, we have Rock Thompson from Rock Exotica joining us. Rock, can you say hi?
Hello, everybody.
So, hey, thanks for joining us here. This is actually a podcast we've wanted to do for quite some time. And a while back, I had an opportunity to tour your facility when I was out in the area, and we were able to connect and set this up. So thanks very much for joining us.
Oh, it's great to have you ask. I'm happy to do it.
So it was kind of funny. It was like a catch up of old time here when we talked to do kind of the pre-podcast, if you will. And we just figured out it was about 1989, actually, when we met.
Yeah.
And so if you want to kind of tell our listeners kind of where, how you got started and the devices and so on, and then we can kind of go from there.
Okay, sure. So back in mid-'80s, I was climbing, and I had a partner that I climbed with quite a bit. And finally, at one point, his wife decided I was a bad influence and wouldn't let him play with me anymore. And I've always kind of considered that a compliment, to tell you the truth. But I'd always been interested in solo climbing, and I'd investigated some of the ways to do that. And they were pretty jury-rigged and sketchy. But I thought more and more about it, and I'd always had liked to make things and design different things. I did a lot of, started out with a lot of woodworking, things like that. So I got into metalworking and tried some different things and came up with the Soloist, which was a solo belay device. And it seems incredible now that I really did this, but I tested it all myself. I wrote an instruction book, and I took an ad out in Climbing magazine, and people started buying it. And even REI carried it, and I got calls from other stores that wanted to carry it. So I would make a batch of 20 or 30 back then, and when they ran out, I'd make some more. Actually, I had a registration card for the users, and I actually called them to talk to some of them and see how they liked it. And it was really encouraging. So at the same time, I was thinking the solo climbing market is such, you could hardly find a smaller market to try and make a living in. So in the back of my mind, I was thinking, I'll never be able to actually eat with this as a business. But I really, really enjoyed it. I enjoyed the climbers and people like that. So I kept doing it. And one day, Steve Hudson called me, and he and Tom Vines were going to be in Salt Lake City at a meeting, and they asked me to come meet him. So I did. And when I made the Soloist, it was manufactured with milling it out of a single billet. And that was unusual because most equipment was fabricated, meaning it's bent out of sheet metal or it's cast. But really, the way you make the strongest, lightest equipment, like for a fighter jet or something like that in aerospace, is you machine it out of solid. And that's what I did. So I met Steve and Tom, and that was quite interesting because they were drawn to talk to me because they had seen a Soloist. And in the Soloist, of course, I was concerned with the force put on the rope in the fall. And so it had a cam, kind of like the rope grabs of the day. But I had invented what ended up being called the curved cam interface, which was instead of a flat piece of metal that a curved cam clamped the rope on, it was curved inside the body that matched the curve of the cam. And so it spread the force out over a much larger area. So I was trying to avoid the point contact that would cause an extreme force on the rope. And it was pretty successful. So what it was supposed to do was then limit the force, and the device would slide down the rope a certain amount to absorb the force rather than break the rope. So somehow Steve had become aware of that. And so they asked me if I could make a rope grab that used that same technology. And so that was my I was an innocent boy from Centerville, Utah, and that was my introduction into what I call the religious wars of the day, which was between mechanical rope grabs and prusik hitches. And I didn't realize until later how adamant and dogmatic different people were about that. So Steve and Tom thought if I could make a device that limited the force, that it would do away with some of the objections that the people that hated rope grabs and loved prusiks, that those guys had. So that led me to work on that. And I actually made the Rescue Center, was what it was called. And then I showed up to the Rescue Symposium in Fort Collins. So at that, I didn't know much and nobody knew who I was. And, now it's amazing how time passes, because back then I was just the kid and, Russ Anderson was there and all these people that I was kind of intimidated to meet, and so I stood up there and I explained what the curve cam interface was. And Steve Hudson was going to carry the Rescue Center. And it got a really big reception and it was great. I met people from Orca and CMC and everybody, and they wanted to buy me drinks after, and it was really a great time. And at the same time, I started to get an introduction more into the rescue world with techniques and other equipment. So I came away with a lot of ideas, and the Rescue Center turned out to be very successful. It was more expensive. It cost about twice as much what the cheaper, easier to make devices cost at the time. But, I didn't care. I never looked at something and worried about what it cost to make. I wanted to make it the best way. And that was what I was there for. And so I never really considered, I've never sat down with an accountant or anything and tried to figure out how to maximize profit. That's not what interests me in this. So I really enjoyed it and really enjoyed the information and feedback I got.
Well, and maybe if I could tell our listeners a quick story, because that's actually right when we met was in Fort Collins at the Naders. And right when you got done with your talk, I walked up to the podium and there was a line that had formed because all of us were very interested in the device. And at the time, I was a CMC dealer. And, I asked if I could become a dealer. And you're like, yeah, sure. And then I said, is there like a credit application or something I need to fill out? And you just looked at me and says, yeah, promise to pay me? I said, well, yeah, of course. Okay, you're a dealer. And that was the process at the time. It's probably changed a little since then. Yeah.
Yeah, it has. But you know what? Still, to me, that's the most important thing. You shake somebody's hand and look them in the eye, and that's the way I grew up. My dad was a cattle broker, and I used to go around with him to ranches and things, and I'd see him shake hands, no lawyers, no contracts, and, your word was your bond. So,
yeah, that's, I felt honored to be one of your original dealers for the rescue centers. So that, and I think we moved to, we sold quite a few of those because compared to everything else on the market, it was a game changer.
Yeah. Yeah, it was real successful, and we later made a smaller size, and we still make a version of that today.
Mm-hmm. And I found it very interesting, too, how it evolved over time, too. That original locking pin design where it was just a simple pin that stuck up with the spring-loaded pin that went through, and then you came up with a really good guard around that then, shortly thereafter.
Yeah. So the original rope grabs that people made were generally, the cam was held in with a quick release pin that had that spring-loaded button, and they had a big flange. So the flange stuck out a lot so you could get your fingers behind it when you push the button. And I didn't like that because it was just a place for the rope to get hung up or to hang up on other things. So that's why I came up with the design I did. I was trying to make it, secure, of course, but low profile. And I thought it worked really well.
Well, it did. And then the other thing that really impressed me, too, was just the simplicity in the design with the keeper on the cam. basically was wire, and that it put just enough spring tension on that to hold the rescue sender in place on the rope, where there were other models, there are other, manufacturers at the time that had like a spring-loaded version with this external spring that would invariably get caught on everything and bend, or had a little piece of web and it was non-locking and would slide down the rope. Mm-hmm. But yours it had just the perfect amount of tension on that with that little piece of wire.
Yeah, that turned out to be, I thought it was a really good way to make it. And it also let, a few people did not want any tension. And then they could just take that off and make it how they wanted.
Oh, interesting then. So, and I can remember when the micro sender came out and everything. And then, because then you became a regular attender at the Naders conference. And I remember you telling a story about you had gotten big enough where you hired your first employee. And he had worked for you for a while, and I think he was looking to maybe get a raise, if you want to tell that story.
Yeah, my first employee was a friend of mine from high school, and then he had gone into the Air Force, and he was very able mechanically, and he was a helicopter mechanic in the Air Force. So I was working in my mom's garage, and I needed some help. So he had a kind of a flexible schedule, and he'd come down and help me, and he was a good machinist. But, I didn't have much money at the time, and he was nice for a while, but then he wanted a raise eventually. And we'd gone out climbing and stuff like that a bit and showing him how the equipment worked. And so I basically, instead of saying, well, you have to be more productive and then we can do this, I set a goal for climbing. So he was kind of scared with climbing. So I think I said, well, if you can do a 5'10", then I'll give you this much of a raise. And he tried, but eventually he came to me and he kind of complained about that, and so I did give him a raise without him ever doing that.
That's awesome. But then you continued on. So what were some of the next products you made?
Well, I made the wall hauler, which was suggested by big wall guys. And then I got a suggestion from a big wall climber to make a swivel. And you might wonder why a big wall climber would want that. It's because if you're climbing Yosemite or somewhere like that, you've got a haul bag. And as you pull it up, it can go back and forth and can contact the wall and twist the rope up. So what can happen sometimes is you get it up all the way to your portaledge and you've got a twisted, gnarly mess of rope. And you have to untie it and hang it down and straighten it out. So a very experienced guy said, why don't you make some kind of a swivel that would avoid that? So I did, and it was a challenging machining operation, especially with the equipment I had at the time. So I did it. I put a ball bearing in there, and I started selling it, and I sold it to a few climbing shops, and I showed it to Steve Hudson. And I went to Naders, and I said, I have something new. This is a solution. It's a great, fantastic solution, but it's in search of a problem. And people thought it was cool, but nobody really knew what they would use it for. And that first year, I spent a lot of time designing that, figuring out how to make it. And the first year, I sold 50, and that's it. Wow. And so, that was the profit margin on that was nearly enough to buy lunch. And that's about it. So I thought, but I did do things like that where I was really interested in things and didn't necessarily do what would make the most money. But the next year, things got a little bit better. And then there were some crazy things that happened. I'd talk to people and they'd say, I was thinking the other day we were doing a rescue and somebody said, hey, if we had one of those swivels that Rock made, that would be really good. And a firefighter back east, Mike Brown, terrific guy, and just like the greatest salesman, if he believed in something, he started using that in training. And rather than swivel, which is just kind of a generic term, he gave it a much more sexy name. He started calling it an anti-torque device. And so things like that, we started selling more and more, and it got up into the thousands, many thousands a year. And that was really good because I had started out machining with manual mill. So I bought a manual mill that has a digital readout at a bankruptcy auction in Utah. And I had a rotary table, so doing any radius on the parts, I had to do them one at a time with a different setup. And it worked well, was great, but it just took forever. And if I had somebody help me, like my friend, they had to really know what they were doing because there were a lot of things that could go wrong there. So with the swivel and the rescue sender starting to do well, I actually took all the money that I'd made and I went down to California and I bought a used CNC mill. It was a simple one, but I was just in heaven because I'd always wanted a computerized milling machine. And I got that home and I got a CAD program that was simple and cheap. And within a week, I was machining parts from it. And I just thought that was the coolest thing ever to have a CNC machine. And so once I got that, doing things like the swivel, it made it so incredible. I had that in my garage. It was tall, so the garage had an attic. I actually had to get a Sawzall and cut a recess in the ceiling to stick the top. So I had to bring it in kind of unassembled and then put the top on it, sticking up into the attic. And it was not enclosed, so it would get chips all over. So we'd machine those, and there would be a pile of chips several inches thick on the floor by the end of the day. And we'd sweep them up, and I'd put them in some bags, and then every once in a while I'd drive them down to the scrap dealer in Salt Lake and sell them back. But yeah, the swivel just really took off and kind of made a lot of other things possible.
Well, I think you hit it right on the head too. All of us, because I was there that when you introduced the swivel at Nader's, and all of us are like, man, that's really cool. I can't think of where I would use it, but that's really cool. And then, like you said, it really became a revolutionary idea.
Yeah. Yeah, it worked really well. And the climbing market was too small, but it really got used in rescue a lot. And then also when adventure parks and climbing walls started to get more popular, that was a big help for those guys too. It was small, light, and super strong. It was 36 kilonewton. So it could be NFPA rated. And we ended up making several different sizes of that. And we incorporated it into a carabiner in a way to have a swivel biner. And it led to a lot of other things.
Right. Well, maybe if I could take a little bit of a detour here, somewhere in there too, you also did some work on some existing tools that had basically been homemade, and you really made it safe. The Alpine brake tube?
Yeah, the Alpine brake tube. That was a very interesting thing. I think that was invented originally by Steve's partner. So yeah, we made a kind of a more professional version of that. And what a great device. It wasn't high tech, but boy, the people that loved it really, really loved it. And it wasn't a huge market, but it did some things so well. Like if you had a long lower, people could pack it with snow or pour water in the tube and cool things down. And it just worked great. So I used it around the shop sometimes to hold things up where we'd lift heavy things up that we had to hold and then lower them down later. And it was a cool tool for sure.
And for our listeners, if you're not familiar with the device, basically it was a piece of tube stock that was vertical then it had like a T, a cross piece that almost made it look like a T. And the original version literally had no safety on it. You just did a wrap around it, and that front T-bar held the rope in place. But if it was to angle off or slip off, the rope could come off. And then you actually designed a screw gate, if you will.
Yeah.
So that there was actually a safety.
Yeah. Yeah. And that reminds me too of another device, more obscure, but it was a zipline pulley. So a twin pulley, meaning they're in tandem. It's a tandem pulley, and then it had a braking lever on it. And Steve's partner had also kind of pioneered that. And that thing was crazy because it was really strong. But if you loaded up a lot of weight, depending on the rope and everything, you couldn't stop on a dime with that. But you could stop and control your descent. So I actually set up a zip line in my mom's yard. I had a tower, and it had a rope that went way over because we had an acre of ground. And so it was fun and it was great, but it was also scary to let people use it because you were best to try that out and be really careful and understand. And then if I had a couple people want to go down 2 at a time, and that made a big difference because there's a lot more weight there. So that definitely was not recommended. But
yeah,
we did sell some of those. Steve Hudson, distributed those. And again, it's one of those things, not that universal of a tool, but the people that had a use for it, they really liked it.
And you mentioned the tower. Is that the tower when Naders was in Salt Lake City? It coincided with the International Rope Science Workshop, and we did drop testing off your tower?
Yes, that is the tower. Yeah, I erected that in the back of my garage using 4x4 steel square tube. And the friend that worked for me, his dad was really an expert welder. So we welded that up. And so I've sold that house. That was my mom's house. And after she passed away, then we eventually sold that. And I know the person quite well that bought it. And that tower is still there.
Really?
I've told him, you need to take that down because it's really old, it's rusty. So eventually he'll take it down. But yeah, it's there. It's kind of a landmark if you know where to look through the trees. And several people that knew I lived there have asked me just what that was. And a lot of people know what it was. But yeah, we had several groups come by and test on that. I remember a lot of people. Arne Larson, who was totally in the prusik camp, he could rig a drop test so that it was very hard on the mechanical device and then pretty easy on the prusiks. And I remember Louis Clem coming there and doing some testing. And we found people that like prusiks like to do tests that show the rope breaking with mechanical devices. But if you actually took a mechanical device, a rope grab, especially if it's a rescue sender, micro sender, if you would just have a small amount of friction, so instead of having it going straight down, you would have the rope go over the steel rectangular tube and then down. And it was just incredible how that made all the difference. So, the prusiks hanging straight down, they tighten up and they slip a little bit, and there's 2 of them. So they really have an advantage in that situation. But if with a rescue sender you're going over a rounded edge, suddenly it just changes the whole scenario and it limits the force by a big factor, and you usually don't have any rope damage at all. So it's all kind of good to keep an open mind and not get too dogmatic about things.
Well, and it's funny you bring up Arne, because I do remember at that session that we had at the tail end, or I can't remember if it was either at the beginning or the tail end of Naders, when we were doing the drop testing, and they were testing different size tandem prusik pulley systems.
Yeah.
And if I recall, it was a 9mm prusik on the rope, and that 600-pound load just cratered into the ground.
Yes. I got to know Arne, and Arne brought me the design for the prusik minding pulley. And
really?
Yeah. So he had approached a couple of other companies, and I won't say their names, but everybody would know them. And they turned him down and said, there's no market for this. This is crazy. So he explained to me how it worked, and I took a look at it, and I kind of looked at how we could make it. Of course, we didn't have a stamp at that time, so we would have to machine that out of sheet, but we could do that. And I rigged up something so I could bend the side plates. And, it made life easier if you used prusiks.
It was a game changer. Yeah.
Yeah, I made that, and we started making it we made the mini size too. And, it's just interesting to think that way back then, I was the only person in the world that would make prusik mining pulleys. And now, of course, everybody's got them, and they're a fixture. So they ended up being really successful. And, I was happy to make those. And I certainly did think that mechanical devices were fine to use as long as you understood the limitations. But also with prusiks, you needed to understand the limitations. And you had to have somebody mind the prusiks. You couldn't just set them up and wander away and expect them to work.
Right.
But yeah, those prusik mining pulleys just took off like crazy, and were another great product.
And actually, you really tied it in nicely, because you think about it, that prusik mining technology and your swivel is kind of the basis now of how many different pulleys out there.
Yeah.
That's kind of become the new standard, if you will, and you see them from manufacturers all over the world.
Yes, you do.
And if I read, you were the first, though, correct, to do the swivel? I
was the first to do the swivel, and I didn't patent that for two reasons. One was I didn't have any money, but the other was that, to me, the idea of a swivel, it was new in that situation. For that use, it was new. But the swivel itself there were lots of swivelly things.
Mm-hmm.
So we got copied a lot by everybody and their dog, but it was a long time. It was many years before people caught on to that. And I'd hear the big companies at different places where I'd meet them, they dismiss, oh, you make some cool things, but there's no market for this. I said, yeah, you're right. So don't even bother, don't even bother making a swivel. And then eventually they catch on when they see everybody, they get reports that everybody's using it. So yeah, everybody now makes those, and just like they make prusik mining pulleys. Prusik mining pulley could have been patented, but a patent would have cost almost as much as I bought my CNC machine for. And so I'd rather spend that money on equipment. Later on, we did patent things, which was good. But at first, you can't afford it when you're a little guy.
Right. But now it's interesting because we carry both, hard-sided and swivel pulleys in our school caches. Mm-hmm. And I'll guarantee you, I know the first thing that everyone is going to grab for, every single time in every class. People just love the swivel pulleys.
Yeah, and that was such a fun project for me to do. I sometimes have done things collaborating with other people, and I like that too, but it takes longer, and often you get started and then you have to go back. And especially if most of the people I work with, they're not real familiar with manufacturing. And the thing, besides working and being cool, it has to be manufacturable. And so on the swivel pulley, I just kind of on my own thought about that for a year or two, and then got really serious about it. And it was just really interesting to me to work with that, because you had to, obviously it couldn't connect the side plates like a regular pulley does, but you've got to have a secure side plate. And it ended up being perfect for Rock Exotica, because the best way to make that was to machine it out of solid. So if you haven't seen what one looks like I think we have some blown up views on our website, but the axle is machined as part of the body. So there's not a separate axle put in. And it just is a very nice, light, strong design. And actually, even if like a regular pulley, if only one side plate is clipped in, they're not very strong. But I think on our standard size Omni block pulley, it still is over 3,000 pounds, even if the side plate is not closed. So
Wow.
Even with that, you wouldn't ever really be able to break it. And then, of course, most of those are NFPA G rated, so they're over 36 kilonewton. So it's super strong design. It uses the same kind of a top as our regular swivels and all. So I like that. Kind of ties in the whole line.
Yeah. Well, and then too, the bearing is so efficient in there. I mean, it's gotten so much easier to haul.
Yeah.
Over the years, when it started with the oil light bushings and then with the ball bearing, and now the bearings you use in those are just incredible.
Yeah, they're really good. And the Omni block is another example of some bigger companies would say, oh, this is nice, but way too expensive. Because, it costs twice as much or sometimes more than a regular pulley. You'll never sell very many of them. And now those guys are copying us because the patent is finally ran out. So
yeah, I have gotten a kick out of seeing the different versions of your original idea out there. It's
yeah,
I guess so. What is it? Don't they say that's the ultimate compliment, though?
Yeah, it's the ultimate compliment. But I wish they wouldn't compliment me. But that's that's what they do.
Yep. But you make a lot of other high-tech stuff. I mean, it's no secret that you make a lot of equipment for CMC, including, the MPD, carabiners. I mean, if you want to talk about any of those devices.
Oh, yeah. The MPD, of course, that was designed by Kurt Mothner. That's a good friend. That was a long development period. He had, I shouldn't say this, but I'll say it anyway. He'd hired an engineer and a professional engineer in title, but I got his files and I didn't think it would work. I didn't think you could release it. And he claimed you could, but I didn't. It had a different way for the gear teeth to mesh on the release lever. So I spent a long time and we made a prototype and it didn't work. It wasn't possible always to mesh the gears and release it. So Kirk hired another guy, and this guy came up with another thing, and it worked a little better, but it didn't really work all the time. So to me, it seemed obvious what should have been done, but Kirk had a lot invested in these guys, wanted to give them a chance, but finally he kind of gave up on them, and we were able to just do something that worked. And then it worked really well, and CMC's done. I mean, that kind of changed things right there. Tremendously.
Completely changed the rescue world.
Yeah. It's expensive because it's a complicated thing to make. It's got the brakes in there. They're stainless steel, and there's some casting on the stainless steel, and then machining too. And it's got a lot of stuff. So like the side plate is kind of extensively bent, but we use a high-strength alloy, so we can't bend it when it's hard. We have to anneal it, then we can bend it, and then we heat treat it again. So It's a great way to do it, but it's time-consuming. But yeah, what a great device. And there's another case where eventually other people come in and are kind of doing the same kind of a thing. So we had to actually, for the MPD, it has so many parts in it, we had to make a different dedicated station for it. And we made a fixture that they would lay all the parts out for that, so that then they just go through sequentially and put it all together. And so one person, it's kind of like the very best Porsche engines in their high-end sports cars would be made by one person in the old days.
Mm-hmm.
And that's what we did with the MPD. One person would put that together, and then they would see from the fixture that all those parts, all the washers, they were all used. And then they would set up for the next one. It's been a really great device that I think people really appreciated it. And CMC's done great with it.
Yeah, and it's still very popular worldwide. A lot of people, still swear by it. So
yeah, we're still selling them. There's a lot of competition, and the competition is good. There are still people that really like that.
And you mentioned something else too. You had like your best person, for that device, assigned to that. But that was one of the things that when I toured your facility here a while back, that really impressed me too, even with the carabiners. how every single carabiner basically goes through a person at a station and is individually tweaked to make sure that thing operates perfectly.
Yes, our carabiners we have a straightening fixture for each carabiner because carabiners are heat treated and then machined, and they have a lot of ways that they can just get slightly tweaked one way or the other. So in a lot of carabiners that other companies make, you can pick them up and the gates will rub on one side or the other. And I don't like that. A little bit of that is acceptable, but generally it's important that the carabiner feels great when you open the gate. And if it's a locker, an auto locker, you can twist it and it feels good. It doesn't feel gritty. It doesn't feel like it's scraping on it. So we straighten those very carefully. And we've gotten good at it because we've made hundreds of thousands of beaners a year, and most of them lockers. So it's easy to make non-lockers. So the climbing companies that make non-lockers, they can make a couple million a year, but locking beaners are harder. And we make a wider variety of auto lock carabiners than anybody. And that's most of our production. Auto lock carabiners are hard to make. They've got a lot of things to think about, like where the sleeve has to synchronize with the frame so that you can't have the sleeve that closes too soon, or then it won't be able to shut all the way. But it has to close and not hang up at the end. So we have a lot of tricks we've learned because we've made millions of beaners over the years. And ours have different features too. We machine the ends of those, whereas nobody else does that. Everybody else stamps them in. But we machine them and we put a little angle on them. And it's not a huge angle like some kind of odd carabiners have. It's just a little bit. You don't really notice it unless you look at it, but it really makes it more ergonomic and better to open. And we also came up with, I always thought that a pull down and twist lock would be good, and there weren't any. But as the way you hold the carabiner, it just makes sense. So I designed that, and we patented some things on our carabiners because we were actually able to, this is a kind of an obscure subject, but normally a carabiner is only strong where the gate is, where the gate interfaces with the frame, the key lock of the frame. But I had the idea to have the sleeve reinforce the gate. So that way I could make the frame thicker and stronger, and the gate had to be a little bit thinner, but then if it was reinforced with the sleeve, it became stronger. So it had the advantage of really making certain size beaners. They were still light, but they were stronger. And they were also stronger if there was a bad loading on it, where it was loaded out towards the gate side. That can make a big difference in how strong a beaner is. And it also made a difference with an inward break. So over the years, it got to be known that, a figure eight or something like that, even a pulley, if it got up on the gate and the sleeve, it could jam and it acted like a big lever. So that's why it's always important that you let your gear line up itself. You're not constraining it. But still, that could happen sometimes. And if that did, and there's a big enough force, you can break the sleeve and open the gate, and then you have a disconnect. So we started making them where they were usually really strong, like 12 to 16 kilonewtons to break it inward. And I tested some carabiners from other companies once, that steel carabiners that everybody thinks are really strong, but they had a really thin sleeve, and if something got levered up on them, they could break pretty easily. So with this way that I was able to do it, you couldn't really, in any kind of normal situation, you couldn't break it open.
Wow. Well, and then too, you mentioned all the different auto lockers you make, and we were kind of talking pre-recording here. You kind of took away some of our shtick where we talk about, all the American-made auto lockers you pull down and the Europeans push up. So, we say we're right, they say they're right. But we can't say that anymore because now, man, you've got ones that pull down, ones that push up, and even ones that are kind of a hybrid between a manual lock and an auto lock.
We made a lot of lift up and twist carabiners for other big companies in Europe. So we knew how to make those. And we eventually, when we had the capacity, we had requests over the years for that kind of a carabiner. There are situations where it's nice in that if the carabiner's hanging down, or if you are used to pushing the carabiner, the top of the carabiner, like against your leg or something, then that helps you do that. But for us, the pull down ones are still most popular. But the hybrid that you talked about is called the Orca, and that stands for open, regular, close, auto. Because I like orca whales anyway, so it seemed like a good thing. That was my excuse to name it that.
There you go.
We had a few people talk about that over the years. Most people didn't think about it, but I thought it was a great idea. It lets you set the carabiner so that you can open it up and it's not locking, but then when it closes, it locks. So that's a huge help for, like, if I climbing, I usually will put that on my gear loop because getting an auto lock, especially if you're in a situation you're trying to place protection as fast as you can, you're about ready to fall anyway, it's disconcerting to have that auto lock carabiner and it's hard to get off your gear loop. So with the Orca, you can just open it up normally, clip it, and let it go, and it's locked. And you can also hang it from a bolt or something. So you hang it upside down from a bolt, and then you can just lift the rope up with one hand and slip it in like it was a total non-locking carabiner. But when it closes, it locks.
Wow.
So
very innovative. Yeah.
Yeah. I had a call once from the FBI. They were training in rappelling and emergency response with high angles involved. They'd had a case where they had somebody come, they were using some non-locking beaners, and then they used some screw locks because they could leave the screw lock undone because they couldn't work with the regular auto locks with what they were doing. So they had a case where somebody clipped in a screw lock and they went over the wall to rappel, but it wasn't locked. And there was a situation where it came open and they nearly, I think they came off, but they were belayed because it was a training op.
Mm-hmm.
So the guy called me, and I'd known him a little bit from some other things they'd done, and they bought all Orcas. And he was just telling me how great that was because it let them clip in like it's a non-locker, but they didn't have to take the time to lock the screw lock or risk forgetting that a person forgot to lock it.
Mm-hmm. Yeah, it's interesting because I'm a big fan of your manual lock carabiner.
Yeah.
We carry screw locks, manuals are the vast majority of what we carry in our caches. And we have some auto lockers in key positions, like on the pick-off straps or Aztecs and so on. But yeah, I love the manual lock, but that's almost like a mechanical rope grab and a prusik thing. Some people are very passionate where they either like or they do not like the manual lock, and there's not a lot of in between.
Yeah, you're right. But the manual lock is really great too, I think, because if you want to lock it, it's super fast to lock and better than a screw lock because, a screw lock always has the chance that with vibration or rubbing on something, it can come undone. But the manual lock, no, it's got that spring that's always biasing it closed. So I've used manual locks. I have screw locks, but in really any kind of a normal situation, I don't use a screw lock anymore.
Yeah. Definitely come a long way since the only two kind of carabiners there were non-locking or screw locks.
That's right. Yeah.
So I was just thinking of one of the other products I saw in your showroom when I was at your shop, and that was the grappling hook.
Well, now there's something that was a terrible waste of time financially, but it was just so cool. I wanted to make it. And we would have that at trade shows and things. And nobody really needed it, but everybody wanted to play with it and thought it was cool.
Uh-huh. Oh, yeah. It definitely has an extremely high cool factor. So,
yeah. And one reason I was able to make that. So when we started out, we had milling machines, but we didn't have much in the way of lathes. So turning machines were not extremely advanced as far as being able to do any milling with what they call live tooling. So you'd usually just turn it in the lathe and have a blank, and then we'd put a gate in or whatever in a mill. But we had gotten a really high-tech new machine that acted as a lathe, but then it would also stop the spindle, and you could mill with live tools that came down. So the shaft of that grappling hook was the perfect part for that because it's turned and it's round, but then at the end where the tines are bolted into it, it's all machined and cross-drilled and everything. So that was a pretty complicated, extensive program where I had to machine part of it. I couldn't stick the whole thing out because it wouldn't have been rigid enough to machine well. So I would stick part of it out, machine part of it, then come in with the tailstock and grab it and pull a little more out and do something else. And so I was really, really proud of that machining program, and I learned a lot with that. And so I just try not to think about all the money and time I spent, and I just try and think about how fun it was to do.
Let's talk about the Vortex.
So the Vortex, a very, very interesting thing. So that idea came from Reed Thorne. He had been in a class teaching in a mine many years ago, and he rigged up with some timbers something that would be an artificial high directional. And so he came to me, and we'd known each other from the symposiums, and he used the prusik minding pulleys. And he showed me the concept, and we came up with a device that could be made out of aluminum and repeated. So we did that. And at that time, I got involved with a European company doing a lot of things for them. And I had a friend of mine who was a very good machinist. And so he took over this first version of the Vortex. And it was popular. CMC did well with it, but my friend had a hard time making enough. He would only make about a dozen at a time. And it was kind of complicated to make. It had some issues because it was assembled with a rotating part that was then anodized afterwards and powder coated. And boy, it was hard to keep contaminants from the rotating area and things like that. So when I had more time and became independent after a few years, I talked to Reed about it and said, we should redesign the Vortex, and I think it can be better. He agreed, so we came up with the current design, and that I had the easel head part you were able to separate from the A-frame part. So if you didn't need the easel head on there, you didn't have to take it. It was much more reasonable to make. It was lighter and more compact. So I think it was really a good improvement. And we started to make them. And up to that point, I'd only had 3-axis machining centers. So you have X, Y, and Z. So we would have to turn the parts if we needed to. But I bought a 4-axis machine, which was just, back when I started, I never thought I'd get to that point. But that was a machine that has a rotary table. So you're able to really do things, turn things to the side that you can't do. So I started designing the new Vortex when I only had 3-axis machines. But by the time the design was finished, I had a 4-axis. And it's a good thing because I would have gone crazy trying to make the Vortex on a 3-axis machine. Because that's turned to all kinds of various angles. And there's some radiuses on the holes that you can't get to with a normal radius tool. So I actually take a very small ball end mill that goes far in there, and then it's interpolating. It's like there's probably 100,000 lines of code where it's just going with a ball end mill quickly back and forth to make a radius. And you can only do that with a high-tech machine like that. That's a 4-axis at least. So that just, was a tremendously fun project, coming up with the Raptor feet and the flat foot. And what a great device that's been for Rock Exotica and CMC. CMC's trained with it, and we've sold that all over the world too.
Mm-hmm.
It's used all over the place. And people have been trained in Europe and Asia, the Middle East. It's just a tremendous product for us.
Yeah. Yeah, we see it. We see it in the backcountry. We see it in like fire department rescue teams. I just worked with a hazmat contractor, basically, and they need it for confined space. We're using different configurations for difficult to enter confined spaces. Yeah, it's just such a cool device.
So one cool thing that I'm reminded of is, again, with the FBI, I heard that they conducted training for what they would do if a terrorist group took over an ICBM silo. And so they had the Vortex, they rigged the Vortex at the top where the missile nose cone is. And then they were training people on, they would be lowered down there. And so they had their hands free with a weapon to shoot the bad guys and save the day. It was very serious. And of course, you want them to be able to do that if they need to. But they also were really having a lot of fun with that training. And said the Vortex was fantastic for what they were doing.
Well, and I think, too, the possibility of other things, other attachments and other ancillary things for the Vortex.
Mm-hmm.
Yeah, without getting into any details, I've seen some prototypes out there from individuals that have some pretty cool possibilities.
Yeah. There's actually a brand new accessory that we're just going to make in the next month or two that it goes on into a trailer hitch receiver. And then you attach the Vortex leg to that. So, yeah, it's a great way to anchor it. And that came about because there have been some people that kind of rigged some things up like that for use with big fire truck. That makes a great anchor for that leg.
Mm-hmm. I'm really curious to hear what the name of that device is going to be when it comes out too. So
it's the Appalachian hitching post.
The individual, I know that he's come up with some really cool designs working with you. I saw your prototype, was really impressed with it. So
yeah, no, he's a really thoughtful guy.
Yes,
I love talking to people like that.
I'd like to sit in a room just as a fly on a wall with guys like you and Kelly Kirk, Reed and all that, just to sit and listen to how the conversation would go. It'd be pretty interesting.
Yeah, I'm not sure we could have them all in the room at the same time.
I think you're right. Yeah, that might be interesting. Some of the neighborhood kids might learn some new words.
Yeah, yeah, exactly. Yeah, there's some great guys, sometimes some strong egos and things like that. But
yeah. But it's good. It's kind of neat when people are that passionate about their ideas. It makes you think, and I think it causes all of us to kind of look at where we've been and where we're going.
Yeah, exactly. I love that they're passionate and they've got strong beliefs, and they should. They've done a lot of work with what they're doing, and
that's for sure. So, and you had mentioned the Enforcer too. We hadn't talked about that yet.
I'd wanted to make a swivel with a built-in load cell. And I looked at some ways to do that. And then I was talking to Kurt Mothner one day, and he mentioned that he wanted to do that. And so I said, well, I do too. I've been planning that, but instead of competing with each other, why don't we cooperate? So we did. And he had met a guy, a software and a printed circuit design guy from Iceland. And that guy ended up being pretty good to work with as far as the electronics on that. And things like that have to be FCC certified so they don't cause interference with airplanes going overhead and things like that. And that's kind of a strange, specialized certification. And he was familiar with that. So he came over and got that done for us. And we made the Enforcer, which is really cool. Our idea for that was regular load cells were always laboratory instruments, very expensive, kind of fragile, and needed to be, certified every year. I didn't want anything like that. You don't need that for rescue. I wanted something that was fairly accurate, but it didn't need to be super accurate, and something rugged, compact. So most load cells are made with steel, but ours is made with aluminum. So it's much lighter. And there were some considerations with that we had to overcome, but it's been a great device, and it's plenty accurate for rescue work, and it's let people really do things and find out things. They can do drop tests with it, static tests, and it lets you find out more about your system if you want to do testing and learning. And if you want to do monitoring, you can do that. Cirque du Soleil use some in various parts of their rig and things like that so that they can just keep an eye on what's going on. Super terrific device.
Yeah. Well, and you look at all the presentations at what it was now ITERS, the International Technical Rescue Symposium. I mean, there's hardly a presentation that's done that doesn't include data from the Enforcer. I mean, that's one of the most common devices used. And I can remember back in the days of NATERS where, I mean, it was a huge high-tech, basically a jump into technology when they started using those initial computerized load cells before the Enforcer. Mm-hmm. Keith Schaefer, I remember from Salt Lake City doing the drop tests with the multi-point anchors. Louis and Bill Clem doing, a lot of the stuff at the Alpine Center for Rescue Studies. I mean, that was pre-Enforcer, but there was such limited data coming out of just a couple different areas. Now, everyone can go out in their backyard and test things as a result of that Enforcer. It's fantastic.
Much easier. I remember those early tests where people had wires all over the place and things going on. And it was not practical for the average person in the field, but now it is.
Yeah, exactly. Well, hey, is there anything else that you want to talk about with our listeners here?
No, we've talked about a lot. I don't want to go over forever. I just will say on a personal note, I've had a lot of fun with this, a lot of satisfaction. And so I feel a great affection for the people that I've collaborated with. And also I'm honored that people have bought Rock Exotica equipment and used it. So I can't imagine doing anything else that would have given me more satisfaction in life. And I don't know what I would have ended up doing, but I'm glad I'm doing what Rock Exotica led to.
Well, I got to say, it was pretty cool to see, when you were just to originally meet you when it was just such a small, company out of, like say, your mother's garage. And now you're an international company with just an impressive, facility, along with all the products you make are just so innovative. It's really been an honor to know you.
Well, I appreciate that. And about 10 years ago, I got some partners come in, and they'll ultimately be the ones that take over once, because I won't live forever. And they've been instrumental in taking it to the next level, because I'm definitely the entrepreneur that doesn't like paperwork, doesn't do all the conventional things you do when you get better. But my partners have put it on a stronger footing and kind of taken it to the next level with all that stuff you need to do that. So it's been great to have them for sure.
That's fantastic. So, well, hey, thank you so much for agreeing to come on and join us on a podcast. And hopefully our listeners enjoyed it as much as I did, because it sure is great hearing the origin and the stories behind a lot of this really innovative gear.
Well, you're very welcome. I'm really glad to be here.
Okay, thank you. And stay tuned for another CMC podcast.